Alright class, in this lesson we're going to work on distributing with radicals. And just a couple reminders is that when we multiply a number times a square root, you just leave the number on the outside. But if I multiply a square root times another square root, we go ahead and multiply the numbers on the inside. Okay? And we also, remember from previous lessons, we have like terms and not like terms based on whatever is inside the root. So keeping those as our background knowledge, we want to go ahead and take whatever number's on the outside, the square root of 6, and just distribute it. And distributing will give me 3 square root of 6, and distributing it to the square root of 2 will give me a positive, because of the plus sign, square root of 2 times 6. And then I got to go ahead and work that further, so it's 3 square root of 6 plus square root of 12. This would be my final answer, but because I can actually do a hockey stick method or the jailbreak method on the 12, I would do a little L right here, and then I can divide by 2, and I'm left with 6, divide by 2 again, and I get 3. Now because there's a pair of 2's, I get to pull 1 out of the square root. So there's a square root, pull a 1, 2 out, the 3 goes on the inside. The square root of 12 actually turns into 2 square root of 3, which makes my final answer 3 square root of 6 plus 2 square root of 3. Now the reason why this is my final answer, once again, is because these are not like terms. I have the square root of 6 and the square root of 3, which are not like terms, and so I can't add the 3 and the 2. Many of you are going to want to add the 3 and the 2, but please do not, because they're not like terms. It's like having an x here and a y here, where it's 3x plus 2y. They're not the same thing, so you can't add them together. Okay? So let's go ahead and try this second example. Alright, in the second example, I'm distributing the 7. Now, because it's a regular number times a square root, you leave the 7 on the outside, 7 root 50. And then it's going to be 7 times negative square root of 18, so it's negative 7 root 18. So this time, I did this first property that we had up top, and now I actually have to simplify by using the hockey stick method. So both the 50 and the 18 need to be broken up. So the 50, I can divide it by 2 and I get 25, divide by 5 and I get 5. Now what that means is that I get a pair of 5s, so I can pull out 1, and left inside would be the root of 2. Now out in front of that, there was this 7 over here. So that 7, next to the square root of 50, needs to remain there. So I need to multiply that 5 that's in front now times the 7. Because, basically, we had 7 square root of 50, which is 7 square root of 50. And we're saying that 5 square root of 2 is square root of 50. So we're basically replacing the square root of 50 right here with 5 square root of 2. Okay? So, if I keep that in mind, that means I need to go ahead and multiply the 7 times the 5 to get 35 root 2. Okay. Now we're going to do the same thing over here with 18. 18 can be divided by 2 and I get 9. And then I take the 9 divided by 3, 3, and I get to a pair of 3s. So I can pull out 1 3 here, and I'm left inside with square root of 2. And now remember we had over here 7 square root of 18, so that means out in front of here we need to multiply this by 7, because again this was 7 square root of 18, and we're saying the square root of 18 is 2, or square root of 2 times 3. So now the 7 just gets put next to and multiplied by the 3, and 7 times 3 is 21, so this is negative still, negative 21 square root 2. Now, that would be my final answer. I would leave it as 35 square root of 2 minus 21 square root of 2, but those are like terms. The square root of 2 and the square root of 2 are actually the same this time, so I need to go ahead and count up how many square roots of 2 I have. I have 35, I'm losing 21, so I go ahead and subtract to get my final answer of 14 square root of 2. So now we're going to further our distributing property and go into FOIL. Now FOIL again stands for first, outer, inner, last. And that's just a process of distributing when you've got a binomial times another binomial. Okay, so we're going to work with our firsts, the f. Okay, the first is the square root of 5 gets multiplied by the square root of 6. That's your firsts. And so that is just going to be the square root of 5 times 6, which is square root of 30. Okay, and then we're going to do our outers. So we'll circle this one, circle this one. Those are our outers. Circle the O. So we match that up. So the square root of 5 gets multiplied by the square root of 2. So really it's just 5 times 2, so square root, so it's going to be plus square root of 10. And that's again 5 times 2. Then we're going to multiply our inners, which is this 3 times the square root of 6, and that's my inner. Okay, so 3 times square root of 6 is just going to give me 3 square root of 6, and it's positive because they're both positive. And finally, we do our lasts. Last I'll do in green, and I'll box the 3, and I'll box the square root of 2 because those are our two lasts, so I multiply them together. Okay, so 3 times square root of 2 is going to give me positive 3 root 2. So you can see you can color match which was the first, the outer, the inner, and the last. Okay, and now we just need to simplify if possible. So far we don't have any like roots, but I do need to do my hockey stick method and see if we can simplify. The 30, I can pull out a 2 and I get 15. I can pull out a 3 and I get a 5. So it's not going to simplify because there's no groups of 2. The 10 is going to give me 2 and 5. The 6 will give me 2 and 3. So this is actually it. This is my final answer because none of the roots will simplify using the hockey stick method. So that's it. That is your final answer for this particular problem. So first, outer, inner, last. So this is your F, this is your outer, this is your inner, and that's your last. Now let's show an example of a more complicated distributing property, or a more complicated looking one. You've got the roots of the third root there, but there's one nice property about this problem, and that is that these are both the same numbers as these ones. The only difference between these two binomials is that this one's negative and that one's positive. Now whenever this happens, what we need to recognize is that these are what we call conjugates. When they're conjugates, in other words, one's positive and negative, and they have the same numbers on the inside, we don't have to do the whole FOIL process. What I do is we just do no OI. In other words, you do the F and you do the L, the first and the last, whenever they're conjugates. Okay, so I only have to multiply the first two numbers together, the 5 times the 5, and that gives me 25. That's my firsts. And then I just have to multiply the last, which is this cube root of 3 times the cube root of 3. And that gives me the cube root of 9. Okay? And because one's negative, one's positive, that's going to be a negative cube root of 9. And that's going to be your final answer. Okay? Unless you can actually simplify. This one does not simplify because I would have to look at the 9 and I'd have to try to do a hockey stick on it. And because I'd be looking for groups of 3 this time, there's nothing I can pull out of there. So, backing up, this is my final answer. So you just have to do first and last as long as you recognize that they're conjugates. It may have looked more complicated at the beginning, but it's actually more simple. Now sometimes you see a binomial and then you see the 2 right there, which means that it's squared. Too often I have students that get excited because they think they can distribute the 2. And sadly you cannot do that when there's a plus sign in the middle. Now you may remember that you've done that before if there was something like A times B in parentheses squared. You could actually distribute it here and get A squared B squared. But the problem is that was multiplication. This one has addition in the middle. Whenever there's addition in the middle, you have to take this and write it twice. And so it's going to be the square root of x plus square root of y times the square root of x plus the square root of y. And that should make sense because when you're squaring something, it means you're timesing it by itself. And so up here, it would actually work out if you multiplied a times b times a times b, you get a squared b squared. Here, it doesn't work out that same way because of the plus sign. So instead, we have to do the full process of FOIL. So multiply my first, square root of x times square root of x. Now, if you multiply anything times itself with a square root on it, you'll just be left with the x. but I'll show you how that works. It's square root of x, and then it would be x squared. Well, square root of x squared, the square and the square root cancel, because the x times x gives you the x squared, and so that part cancels. So now we do our outers. That's my square root of x times square root of y, and that is going to give me square root of x y. There's nothing I can do with it except put them on the inside. And then I need to do my inners. So inners are square root of x square root of y, so it's going to be plus square root of x y. And then finally my lasts, I multiply the square root of y times the square root of y, which is going to give me just a y, but I'll just write that it's plus square root of y squared. Now again, the square root and the square cancel each other, so you're left with y plus, you have two of these, I'm sorry, I should have put x first. So it's x plus 2 square root of xy plus y. Okay? Because again, this simplifies to just be an x, the square root of y squared simplifies to be just a y, and there were two of these in the middle, so that turns into 2 square root of xy's. And this is your final answer for this problem.